Good evening and welcome once again to our video or our YouTube channel, which is called Pearson and Excel International Maths by Mr. Kamotho. We have been explaining this book since the chapter 1. Now we are in chapter 5, Exponentials and Logarithms. Please note that this YouTube channel will be having Pearson and Excel International Mathematics explained from Pure Mathematics 1 to Pure Mathematics 4, and also International GCSE Mathematics. Let us get to page 104 and understand example 2. Let's talk about example 2. And in example 2, we are told that sketch the graph of y is equals to a half x minus 3, that is the index, and give the coordinates of the points where the graph crosses the y-axis. And I want to explain this question in two approaches. I want to give this question two approaches. And number one, I would want to say that if fx is equals to a half raised to power, let's say a half raised to power x, just that, a half raised to power x. It follows therefore then that fx minus 3 is equals to a half raised to power x minus 3. Note that it is the index that has changed. The index here was x, and that's why we had the function of x, but the index here is x minus 3, and that means if the first was fx when x was at the index position, then and the second the index has now changed to x minus 3, that means automatically that is fx minus 3. And where am I coming from? You realize that if fx was a half raised to power x, and that means we had a graph that looked like this. That means we had a graph that looked like what we had in the previous. We had a graph that looked, this is obviously one. We had a graph that looked like this as understood in the previous example. And this graph of y is equals to a half x, or rather fx. Now, we need to go back to our understanding of the Mayo. We need to go back to our understanding of the Mayo and say something about Mayo, because we can already see that this graph, when we're talking about fx minus 3, this is already addition inside. This is addition inside. We have a negative a there. We have 1 over a there. We have a there. We have a there. As teachers should value holiness, then this one is clearly addition inside. And addition inside is a horizontal translation of negative a steps. A horizontal translation of negative a steps. Now, our a happens to be minus 3. So, it is horizontal. It is a horizontal translation of negative minus 3 steps, which is actually 3 steps. What does this mean? Since it is horizontal, all x values plus 3. All x values plus 3. We may be interested, if it is all x values plus 3, we are going to be interested, where does the graph cut the y-axis? And because all x values will move to the right 3 steps, when x was a -3, after it is going to move to the right 3 steps, x is going to be 0, because -3 plus 3 is going to be 0. So our interest would be, what was the value of y when x was a -3? And it follows that this is going to be y was a half raised to power -3. And this, as we said, it is 2 raised to power -1 raised to power -3, which is 2 raised to power 3, which was 8. So that particular point, y was 8. So our new graph looks like, it simply has the same shape, but obviously that point is very conspicuous. That is going to cut the y-axis at the point where the value of y is equals to 8. And this is the graph of y is equals to a half x minus 3. Now we can also explain this particular point if we take the general equation to be this. At this particular point, you can already see x is equals to 0. We can be having an otherwise. So when y is equals to a half and x is 0, 0 minus 3. So it remains y is equals to a half raised to power -3, which is basically an 8. It's another way of explaining the coordinates 0, 8. And that is the first approach of this particular question. And I want us to go to the second approach with a different transformation and have it this way. If we talk about the graph of y is equals to a half, x minus 3 is the same as a half raised to power x multiplied by a half raised to power -3. Because we know very well, when a raised to power a times a raised to power b is equals to a raised to power a plus b. This is what we had here. This particular arrangement is what we had here, but we have been able to separate the terms into this particular format. And therefore, our new value of y is equals to a half raised to power x multiplied by a half raised to power -3. And what is this? Let us talk about a half raised to power -3. But a half raised to power -3 is 2 raised to power -1 raised to power -3, which is 2 raised to power 3, which is basically 8. We have seen this elsewhere. So we are going to have our new function to be y is equals to a half raised to power x multiplied by 8, or rather 8 a half raised to power x. And since this was a function of x, then we are going to have 8fx. And look at this. We are going to have 8fx. Look at this. This is multiplication outside. And multiplication outside is vertical stretch. This is vertical stretch of scale factor 8, because our A is 8. We are talking about vertical stretch of scale factor 8. That means what? Y is equals to a half raised to power x is going to be vertically stretched by scale factor 8. What does this mean? It's going to be the original function y is equals to a half raised to power x is going to be vertically stretched by scale factor 8. That means all y values times 8. Let's see what we had originally. The graph of y is equals to a half raised to power x was that, and this was 1. So when this one, the graph of y is equals to a half raised to power x was this, a half raised to power x. That was the graph. So all y values times 8. This is quite a conspicuous y value. So 1 times 8 obviously is going to be 8, and the shape of the graph remains the same, but this particular point is now 0, 8. So this is the graph of y is equals to a half x minus a 3. Just note the difference. It just climbs along the y-axis, all y values times 8. That is why when y was 1, then 1 times 8, we are having our new y to be 8. So the y-intercept of the new graph is 0, 8. And that is just like it. Please note the two explanations which lead you to the same conclusion. We could be talking about horizontal translation or vertical stretch. Horizontal translation or vertical stretch. They will lead you to the same kind of graph. Fine. Follow my YouTube channel again, Pearson Excel International Maths by Mr. Kamotho, and subscribe, share, and of course like, and let's walk together this journey of international mathematics.